we're looking at the Tech Fireside chat with some of the smartest minds I've ever met. We've got Seth V, Wyatt, and Ryle. Of course, I'll let you gentlemen all introduce yourselves and talk a little bit about who you are. Of course, most folks know who Wyatt is as the guy that ideated Constellation's hypergraph transfer protocol. So with that, I want to give a big shout out to Seth because I just met him in person for the first time, but he's been part of our community for quite a while and has played a huge role in educating a lot of you, including myself, on the capabilities of what we've got going on. And then, of course, we also have Matthias, who's joined us. And I think that Matthias is, a face that I'm never mad at seeing. So I'm glad you're here, Matthias. And I'm going to go ahead and turn it over to you for you all to take this on. Played a huge role in educating a lot of you, including myself, on the capabilities of what we've got going on. And then, of course, Matthias, who's joined us. And I think that Matthias is, a face that I'm never mad at seeing. So I'm glad you're here, Matthias. And I'm going to go ahead and turn it over to you for you all to take this on.
Hey guys, my name is Seth V. I'm a technical community lead here with Constellation, and I've spent a lot of time past year or so diving really deep into hypergraph transfer protocol, reading all the white papers, watching all the videos, and trying to synthesize all that information in like a way that's digestible for you. Of course, that's mostly my interpretation of all the facts, right? So what we have here today is a great opportunity for me to ask some questions that I've heard throughout the year or so from the community that I'll be able to pose to Wyatt as well as Matthias here. So before I do that, I guess if you want to just introduce yourself, Wyatt, and Matthias, go ahead.
It's always really hard to introduce myself for Constellation because I do it all, but I'm Wyatt. I'm a member of the founding team, and it's a pleasure to be here.
Hello, everybody. Pleasure being here. I'm Matthias, one of the co-founders of Constellation, and you'll hear a bit about our thinking today. So I'm very excited about that. Very good energy in the gym, and let's kick it off.
Great. All right. So I have a couple questions here already prepared. The first one's to Wyatt, actually. It's something common that we all hear about. And that is, how does hypergraph transfer protocol support atomic transactions between networks?
It's a great question. So the core about how atomic transactions between networks are something equivalent to some type of swap, how all that works is essentially baked into this concept that we all know as the L0 standard. So as being a standard, essentially, this is some type of an interface that's meant to be replicated by programs that do relatively the same thing. So you guys might have heard of like the Rosetta standard. That's a set of endpoints that L1 and base layer protocols can interact with exchanges. And it's a standard that allows for integrations to be a lot easier. You guys all definitely know about ERC20. It's a collection of methods and functionality that are common and replicated by, and extended rather, by those types of token use cases. So this L0 standard is really, we could think about it as just another process that would sit alongside a L1 node and an L1 network. So like a Bitcoin node, an ETH node, a DAG node. And essentially this L0 process would ferry information between these L1s, keeping track of its own sort of like meta ledger, you could say, where it keeps track of both sides of this transaction. So I can get into a little bit more about DAG and the DAG L0 as well, and design choices that allow for this type of data to be validated and for individuals to register their information in real time on some type of a ledger that doesn't need to worry about like injection attacks. But I could say that just in the simplest case, by running this L0 process, it'll be able to create some type of a like meta ledger between ledgers, and then it's able to keep track of the context of consensus happening on both of those L1 protocols. And so it essentially sort of connects in like a multi-phase way a flow of information between these networks.
Great. So that's kind of like the idea behind connecting state data between networks, essentially.
Yep, exactly. And so state data is, ledger state, ledger, what's in your ledger is really like state information, like the current state of a system, how it evolves.
Got it. Thank you. Appreciate that. So the next question, also Wyatt, how does HTTP's pro consensus algorithm prevent denial of service or spam attacks on the network?
It's a great question. And so I will say also too that, what can be done in the future with this model, I think can really be extended to do just a lot of things, not just look for pure health and sort of factor that in, which is part of the current scope. We can do even more complex stuff in the future. So just to keep that in mind. So essentially, the reputation model relies on some type of starting, state data, but it's basically like a set of addresses for nodes and some type of a score that we want to assign for how well we trust some type of a node. It's really just sort of like a starting baseline point. And so when we start the network, all the node operators, ideally should know each other and set really strong scores for their relationships. Over time, as new nodes want to join the network and join the pure join pool, then they can be cycled in and out over time, essentially giving new people and new nodes and new servers opportunity to participate in the network. And so the goal here is that we want the model to maintain the best scores that it can between nodes, and what that score represents is how well it's able to process data, perform consensus. Does it fail a health check? Is it still online? And so over time, as nodes are both participating and inside of the pending pool, whether or not they do the correct thing or they correctly don't do anything factors into that score. So over time, you could really think of the reputation model as almost being kind of like its own DAG or like its own tree that evolves over time based upon the servers that are available and have elected to join. So it's kind of, I've never really seen anything like this, at least on a consensus problem, but it's really cool because it kind of flips it all on its head. In a lot of ways, it's like, proof of work in the sense that it can handle like an open network and gets around some of these, things that it's just sort of the approach around like staking. But yeah, I think hopefully it might turn into some kind of like a gamification. And so I think that's really from like the consumer side, what we're going to see is that Constellation is going to create, or basically at least just out of HTTP, it is possible to create some type of almost like consumer type, product around server and node hosting. So yeah, I am really excited for that future. And if I could wave a magic wand, I think that's how crypto should have been a long time ago.
Great summary. I don't think I have any follow-up questions, to be honest. I think that was pretty clear. And my next question is actually to Matthias. And that's kind of a broad question, but what are the main components of a successful token model in your eyes? And I guess how does that relate to Constellation?
Well, okay, that's a very broad question.
I know.
So, let's step back, okay? So if we're talking about token models and what is commonly known as tokenomics, right? We're talking about the backbone of incentivization that makes a decentralized network work, right? Mm-hmm. And what's really important is I want to paint a bigger picture, right? So anybody of you who's building, who wants to build, we've always stressed a lot how important it is to nail the economic aspects of whatever you're doing, the tokenomics, right? You want to nail that. And in order to really understand that, I encourage everybody to really dive into first principles, which is starting with Bitcoin. And Bitcoin basically has that, what everybody should know in here is the proof of work consensus mechanism. And that ties basically right into what Wyatt has been laying up here on the technological side, because that ties into the value proposition on one hand, but also on the fundamental metrics of how our network actually functions. And then in extension of that is being governed. So from Bitcoin, which is basically a transmutation of computational power, speak electricity, into an output, which is Bitcoin. In that sense, Bitcoin is a true, how is that called?
Commodity?
A commodity. Thank you. So Bitcoin is a true commodity. So all these critics in the early days that were like, oh, Bitcoin is just something made up. No, in the digital sense, it is a true digital commodity. So now Ethereum took the proof of work, but then they, you know, obviously everybody knows they're going now to proof of stake. And proof of stake, in my opinion, personally, is just a cop out, right? It's like, yeah, all this energy usage, blah, 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 but this is not true anyway. I can, you know, different discussion and why that discussion happens right now. But anyway, proof of stake is kind of like the lazy man's way out, because basically they're skirting the consensus mechanism. That's what proof of stake basically is. They are not really doing the hard work on the consensus. And we all know, you know, all the scaling problems. That's why we have layer 1, layer 2, all these issues. And that's ultimately what led us and Wyatt to really develop Constellation, is a solution around the consensus problem. And when you talk about a scalable consensus that is tied into network economics, into tokenomics, well, you got to come up with something very different. And if you look around, 2017 was the phase of the protocols. Everybody launched a protocol. How many of those are still around, right? So not that many. And all they did is they copied the Bitcoin model with a disregard to how their actual own consensus mechanism worked. And now let me close that off in a broad loop. How that connects to us is basically we have developed a new consensus mechanism that allows for streaming data validation, which means huge amounts of throughput, huge amounts of data. Now, if you then really digest the way how this consensus mechanism works, you need to come up with a different way how you do tokenomics. And I just want to paint a very broad picture, because we've outlined that already in 2019. And like Ben said before, we've done a lot of visionary groundwork very early on. And if you check my paper on the tokenomics from 2019, you will find the very thoughts that are coming to life expressed now in all the companies that are building, in our visionary, and what Ben wrote recently. So that's all still there. But long story short, it basically means that our rewards mechanics need to be adaptable to the consensus mechanism and thus scalable in a very different way. And how we've done that is tagging DAG to throughput. We have the rate limiting for free transactions, and that's unlike anything else you've seen in the industry. And then we're working on some models that go into a very novel way of governing the network. And we're really trying to spearhead how Constellation is governed and how reward mechanics work. So everybody who builds or wants to build on Constellation really needs to do a deep dive on those tokenomic aspects and to understand what it means to run a business model with true utility that processes data on a distributed ledger technology. And if you then thread it from the business model, from the true utility, you will see that there are very different mechanics that are involved around how you structure that, which will lead into a couple of legal aspects. Our legal system is not quite prepared, in my opinion, to anticipate what we're building on here, because it transcends traditional boundaries of securities and utilities. It kind of like merges it. And then there's multiple other ways how these reward mechanics are built on state channels, on data communes, on basically making a state channel a data collective, like Ben has outlined it on Lattice. And if you then spin, what does that mean for the world? That's a whole different economy, a whole different way of how you can do business with and on a blockchain. And that's what we're really here to do. We basically fulfill the original promise of Ethereum to take every business onto a blockchain. So that's why I can only encourage everybody really do a deep dive into tokenomics and the economic aspects in regards to our consensus mechanism.
Beautifully stated. I think one other thing to add, and I like Ben Jorgensen's, your recent BitFi interview, you compared, and goes back to what you were just saying about Bitcoin, where it's transmuting energy into value. And now this is an extension beyond that, where we're actually transmuting data, which is very specific and custom to the context, right? And then commodifying that into something that's interchangeable and validatable. But yeah.
So one last sentence to that. So I hope everybody who's here and everybody who's listening right now, That's their Ethereum DEFCON 0 moment for DAG right now. So that's my big hope for today. So I leave it at that.
Awesome. All right. So I think this is a really good pivot here and it's like related to what we're just saying. This is to Wyatt. Are state channels flexible enough to comply with any industry technical standard? So let's say, the big term out there is ISO 2022, the financial messaging standards. There's a whole host depending on the data set in the industry, how they have different standards. And I think really it's rooted in understanding are state channels flexible enough to just simply adapt to those standards and deliver on those standards?
I must be honest to say, like, is something going to work for everything? I mean, that kind of, I don't know, it's a
dangerous,
well, I mean, to try and, say all things are this is, in this dimension, it doesn't really work that way usually, but I mean, the intention was to allow for interoperability through the L0 standard. And so as long as the standard is, I guess, limited towards like access of data and just like the external endpoints that are being used, then I think that would cover like a wide range. But again, I unfortunately can't speak to like everything and things I don't know about. Sorry.
Yeah. No problem. I mean, that's you can't speak to the definitive nature of every single standard and how, got it. Understood. I was going to ask Matthias another question, but you already answered it in your other statement. So I'm just going to go over that. The other thing to Wyatt is related to how does Hypergraph Transfer Protocol, how is its approach to horizontal scaling different compared to like, traditional approaches that involve sharding a database? I think that's a big thing that I hear a lot.
Yeah. And, I've been getting this question since the very beginning. And the answer is really kind of like a story or like a history lesson about common, just like architectures for people's systems. I don't know, that's super vague, but basically like 10 years ago, if you were a traditional company in Silicon Valley, I don't know exactly what your app looked like, but essentially you had some kind of an entry point that was running like what has been deemed like a monolithic like service or like basically something like Rails. And so you have this huge program that's whole job is to try and ferry interactions back and forth that's wrapping all of these different sub processes, sub programs, and essentially creating like a bottleneck. And so I actually remember I gave a talk in Singapore about this and I showed something called the Death Star diagram. And so essentially, when you're working at a company or you're trying to build something that's supposed to work at scale, right? What you really want to do is figure out what is the cost necessary to make this thing scale? And like, is it possible to just hit it with more machines? Because that at least gives you flexibility to provide the services that you need for your customers, right? And so this problem I mentioned about monolithic architectures and the scalability problems they had was actually really common at like Netflix, Twitter, all the social companies. This is like Web 2 and when cell, apps were getting really big. And so, without rambling anymore, we had this advent of like a microservices architecture where essentially we tried to think about the different components of our application independently and trying to sort of remove some type of a centralized orchestration of the data flow throughout the network. And so that is kind of an evolution as well So in addition to that, maybe even a bit further down the line, we have the advent of MapReduce. And so essentially that was kind of like the umpteenth example of, can I hit it with more machines, make it run faster and better? And so that whole concept was sort of moved away from just like the architectural approach to also changing how the data layer worked as well. Whereas, databases like MySQL would use something called sharding where they have subsets. Think about it like all the data inside of your database, like a pizza. And then you'd have all the different slices. And so you would put like 3 slices on each shard and then have one overlapping slice so that you could run multiple different jobs on these different servers that were, supposed to be responsible for a certain subset of that data. And so that took it an even further level. And so the furthest and sort of what's being used now in like the streaming, sort of like streams on MapReduce, obviously Spark streaming, but you can take a look at the same kind of stuff in like Flink. Obviously, if you want to go look at, anyway, I'm going to go there, but basically the advent that moved there is what we call dynamic partitioning. And so essentially that is where data is constantly, how to put this? Data is constantly moving through different sub part files such that the total set of operations on that data are optimized and streamlined. I know it's a big mouthful, but whereas, sharding actually uses like, replication, or rather replication and also redundancy in order to try and speed things up, which has a cost around the data storage layer. This dynamic partitioning part, it does not. It kind of moves away from that. And so basically, if you just follow the history of modern software architecture for the last 10 years, it's basically like crypto is almost kind of like 5 years behind. Bitcoin came out and it had the exact same model that we saw, like that, honestly, like Twitter and Facebook used when they first built their apps. And so now we're kind of seeing that change all throughout just the ecosystem. You see it with the sharding approach with Ethereum. And so, yeah, I think folks have been talking about sharding. And so I'm hoping that this word dynamic partitioning, which if I had a nickel for every time I said this phrase, yeah. Anyway, I think people are going to start talking about it, and I can't wait until that concept and how do we actually try to like do something like MapReduce over consensus becomes something that not just we talk about, but that crypto as a whole realizes, hey, this is like how everything else works. Like maybe we should start to go with the flow instead of trying to say, hey, you should adopt us because our way is better, even though it doesn't kind of fit in with how the world works now. I don't know, but yeah. I'd love someone to do a count on how many times we've said the word dynamic partitioning in the last 6 years. So
I could give you some new words that I came up with. I don't know if they're correct, so I'd love to know if you think they're correct. I came up with topological partitioning.
Yeah, so we were chatting, and yeah, so I mean, if you were to actually think about like the hypergraph being this network of networks which sends data across different nodes forming like a surface as opposed to a link, then I would say yes, I think that's a valid term. It is new, as is cellularization, but I really like that, dude, because like it makes sense because it sort of just ties it all together with that cellular interface inside Tessellation, which is where all this stuff comes from. And so to even give you one more like just jump back for anyone who's listening or whatnot who does front end like web dev, basically it's just a future. Like you have a future that runs consensus and you just treat that object as though it's already done, and you write your program as though it's just going to get that and move on. So these are all things that we're using in our day-to-day life, and hopefully people will be like, oh wow, like I can stand up a state channel, like how I can build like something with React. So that's the goal.
Awesome. Okay. Thanks again, Wyatt.
Thank you.
All right, I have one last question. I think we can fit it in. So it's not for you. I'm sorry, dude.
I'll be really quick. I'm sorry.
Do you have something to say, actually? Do you have anything that you want to talk about?
Well, I don't know why I'm sitting here. Just kidding. Go at it.
Okay.
Go at it.
Okay. So the last one, and it might actually relate to the tokenomics side as well, is can you elaborate on the variables that impact nodes prod score?
Yeah, so right now the focus is on what we call the pure health check. And so, I mean, there's just kind of two different things here. Like one, if a node actually is Sybil, someone modifies the source code, there's a bunch of different ways we're going to figure that out, which maybe to make it slightly harder, I'm not going to tell you, but one of them is that if you make fake data, like we're just not going to process it. Obviously, that's fine. However, in order to make sure that the cluster is resilient, and I mean inside of the cap, I'm not going to go into cap there right now. I said I'd be fast. Anyway, basically, we're really focused on cluster stability and pure health checks to make sure that all the nodes are online and can process stuff as fast as possible. So we do have mechanisms for correctness in place. We haven't gone as far as trying to take into location like IP, like lat-long data to think about minimizing the actual distance over network. These are the types of things that we could, add in to improve. But it really, I mean, I'm telling you, if you go look in Constellation, like it sits very closely and operates on top of the pure health check mechanism.
Great. All right, great. Yeah. Let me just come up with, I think I have some live feed here actually. So let me just
keep them coming.
Dip in here. I think I asked this, but maybe it's a different way of asking the question, Matthias. What are the main components of a successful token model? Is that similar to, I don't have Lifecycle? So, okay, let's look at it from a state channel perspective. New state channel, they're trying to understand the entire life cycle, from when they introduce the token, what variables that they need to consider as they integrate it into their technology. And at the end of the day, like at the end of that, where does, whether that's like going off ramp or if that's being, converted into some other utility, through interoperability. Does that make sense, that question?
Oh yeah, that question makes a lot of sense.
Okay.
It's just too specific.
So,
yeah.
First we went broad.
That would be an easy cop out, right? So if I would give everyone here a schema to do their business on DAG, then I would take away 95% of all the business models that are floating out there in the ether, right? So and that's really what I can give you though, is basically a generalized what I call the token life cycle, and we've written about that. Is how actually in business speak, the life cycle of a token from inception to full market maturity, how that looks like, right? And that's a slightly different angle. It's a broader picture, because if I tell you, okay, well, if you want a specific model, how incentivization in a token model on L0 works, then I would recommend really look into the Alchemy white paper, into what Alchemy has done. And that's very specific to their business model. And that's what I meant before. It's super important. This is not 2017. This is not DeFi yield farming either. Like these are, in my opinion, rather simplistic models that are based on, basically cut and paste from what's been done in 2017. There is no true innovation in there. However, if you look at, for example, what Alchemy is doing, it is tied to true utility. And then the token plays a fundamental role that is way beyond speculation, because you're actually creating value for your user base. And it's a mechanics of adoption. So if we're now talking about what I call token life cycle, that's the full cycle from, okay, I want to do business in and with a blockchain in crypto, so to speak. Okay. Then you need to have a plan. You need to create your tokenomics. What kinds of, how many tokens do you mint? What are they used for? What is the true utility of my token? What is the legal aspects of that? How do you put that all into a cohesive framework that we call tokenomics? And then you create an Excel sheet or so on. And you have these models that you create. How many tokens do you issue over a certain amount of time? How does that conflict with or not conflict with the legal area that I'm situated in? A lot of things are not possible in the US. That's why a lot of things are offshore, right? So you need to take all these considerations into account. And that's all why we say it's so important. It's the spine of doing business in crypto. And if you have a lack of understanding there, then I can really encourage you to do reading and more research, because it's super important. It ties into every single strategic decision. It ties into the way how you talk to your users, how do you acquire users, how you're marketing, how you talk to token holders, how you, like all these things. Every single aspect of what you're doing as a crypto entrepreneur is tied back to that life cycle. And if you mess up those tokenomics in the beginning, you'll pay dearly for that over a period of years. So that's the first step, right? So that's even before you start. Then the second step is, okay, now you mint your token. Okay, you go on a launch pad like Lattice. You have some public buy-in and people, from the community who come in there. And that's your first exposure to, you could say, almost like a public fundraising round, even though it's slightly different. And you have your first exposure to the potential user base that you're acquiring. And GeoJam is a good example of that, you know, how they interface with their users, and they have an app, and that's their first touch point with the public. And then ideally, and that's what we're building towards to a Constellation, third phase, basically the second phase is the distribution. Okay, that's the collection phase. And then the third phase is now you're at market. You're a publicly traded utility token, right? So what do you do with that? Like, that is a shifting of gears between how you did business in the first two phases. You need to shift gears significantly as a team in your operations, in your thinking between those phases. And if you're slack in shifting those gears, you'll fall behind, and then you're like, oh, I don't know what to do. Well, you need to shift gears. You need to do something else, and that something else is determined by those phases in that token life cycle. And that next step is an exchange, right? You need to create utility by having your user base interact with your token. And, you know, if you just mint a token on Ethereum, nothing happens, right? Or even on DAC, right? It's just sitting there, right? Okay, cool. Two people own it. Okay, so you need to create liquidity, and liquidity comes with an exchange. So you need to create dissemination of that said token. And we have luckily now two ways how to do that. One is through DeFi, decentralized exchanges. That's, you know, anybody can participate in that ecosystem, which is a big revolution in how value can be transferred and put onto the street, basically. And the second way is centralized exchanges. And that's a big BD effort for anybody out there. If, you know, these things don't come easy, sometimes there's years and years of you know, relationship building and so on that goes into getting on a centralized exchange. Okay, so let's say,
Before, can I interject?
Yeah.
Is there, would you argue there's a third way, like specifically GeoJam's app, where you'd be able to actually procure that like within the user experience itself versus having to go to a like exchange to actually, as long as provided there's an on-ramp, I guess, right?
Right.
Yeah.
And that's actually a really good point, because we're talking about dissemination and on-ramp, right? How do you onboard people to your app? How do you create utility for your token? Okay, an in-app purchase is such a function, but in the wider sense of an ecosystem, you want to get a step further, right? You want to get it wider out there. You want more users. You want more adoption. So the next step in the logical consequence is actually to go on a DEX or on a SEX, a centralized exchange, to create that utility. Yeah. So that's step 3. Okay, and then we shift gears again. So we already like
you put the new nitrous boost on.
So we're already 2 years into the journey. Don't forget that. So we're 1 to 2 years into the journey. Now, last step is, and I'll make it short, is to create full liquidity. For full liquidity means you can now go as a token issuer into treasury functions, into advanced, you know, modeling of your liquidity. You can attract more liquidity through cross-chain interactions and you know, LP programs and so on, leading into other ecosystems. But that's the maturity where you reach full economic utility, and that's what you're ultimately shooting for. And if you can't reach that, you have failed as a token project. So liquidity is king. That's the ultimate short message here.
Okay, so thanks again, like both of you. Like, it's an honor, by the way, to be here. Thank you so much just to invite me up here. Like, truly, like I did not expect it. Thank you. Thank you. I'm gonna switch it over to Diggles now. So back to you, Diggles.
Hey, I appreciate it, Seth. A lot of smart brains right there. It's been an honor to work with Matthias and Wyatt through this over the last 5 years. And as you can tell, they know a great deal. And Seth V, wonderful job moderating there. Hopefully everybody learned something interesting. I certainly did. And I always love hearing you guys talk. So well done.